This is Miss Humbert here. Today we're going to be doing the second notes of Unit 5, which is talking about similar polygons. So this is going to be using a lot of the ratios and proportions and stuff we were talking about yesterday. So let's go ahead and let's take a look at this note sheet. So first and foremost, when we talk about similar polygons, okay, two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So what does that mean? Well, that means that we know that all of these angles are congruent. So angle A is congruent to angle W because they each have one arc. So angle A is congruent to angle W. Next, notice that B and X both have 2. So angle B is congruent to angle X. Then for C we have 3. So angle C is congruent to angle Y. And last but not least, angle D is congruent to angle Z. So not only do we have to have our angles congruent, we also have to have our sides are proportional. So what we need to do is take our corresponding sides and make sure that all of our ratios are matching. So AB goes from 1 to 2. So AB corresponds with WX. So we have 15 divided by 5 for our first ratio. And that fraction should be equal to BC over XY, which is 12 over 4. And that should be equal to 21 over 7, because that's our next pair. And then that should be equal to 18 over 6. So now we want to make sure that each of these are going to be equal to each other. So 15 divided by 5 is 3. 12 divided by 4 is 3. 21 divided by 7 is 3. 18 divided by 6 is 3. So we have 3, 3, 3, 3. So all of our sides are proportional because they have the same ratio. So that's what makes these polygons similar. Let's take a look at number 1. So for number 1, we know that it's similar. When you have this little tilde sign here, that means similar. For congruent, it has an equal sign underneath. But if we just have the tilde, that little squiggly line, that means that they are similar. So what do we know? Well, we know that angle F corresponds with angle J. So angle F is congruent to angle J if they are indeed similar. Likewise, G needs to correspond with K, so angle G is congruent to angle K. And angle H needs to correspond with angle L. Okay, so all of those are our corresponding angles. Now let's write a proportion for our sides. Okay, so to write our proportion, let's take a look at our letters. Well, FG needs to correspond to JK. So FG divided by JK, that fraction there, then GH needs to correspond to KL. So then GH needs to correspond to KL. So that ratio has to be equal. Lastly, FH, so the first and the last, needs to correspond with JL. Okay, so all of those fractions have to be proportional for those two triangles to be similar. Let's take a look at number 2. So for number 2, it says triangle ABC is similar to triangle XYZ. Now state the scale factor. Well, here we know the length of AB, and we know the length of XY. Well, those two sides, since it's similar, need to be proportional. So let's set up that proportion. I'm going to do AB divided by AC. So 6 divided by 3 is going to give us 2. So all I did was divide two corresponding sides to get my scale factor, which is 2. Let's take a look at number 3. So for number 3, we have two photo frames. One is 4 by 6. The other is 8 by 10. So now we need to figure out if they're proportional. So to do that, I want to check to see that their fractions are equal. So I'm going to take my first photo frame up here, and I'm going to take the smaller side, and then I'm going to put that over the smaller side of my second rectangle. Then I'm going to take the larger of my first rectangle and put that on top, and the larger on of my second rectangle on the bottom. So notice my second rectangle is both on the bottom. My first rectangle is both on the top. You need to keep them on the same top or bottom. So let's see if that's true. 4 divided by 8 is 0.5. 6 divided by 10 is 0.6. So those ratios are not congruent. So these are not in proportion. So when you blow up a picture to be 8 by 10, it's bigger to put on your wall or something like that, it's actually not proportional when you do that. So your picture's out of proportion. Next, let's take a look at number 4. It says determine if these triangles are similar. If so, write the similarity statement. Well, what's given to us? Well, we know that angle N is congruent to angle R just by those angle markings. Angle Q is congruent to angle S, again, just by those angle markings. Well, think about it this way. Those two angles are congruent. It has to add up to 180. So it actually means that angle P has to be congruent to angle T in order for that to be able to add up to 180. So angle T. Okay, so now we got our angles. Now we need to check to see if our sides are in proportion. So NQ is the same as RS. So I'm going to write 12.5 divided by 10. I need to check that proportion. Then QP is the same as ST. So I have 11.5 divided by 9.2. And TR is the same as NP. So I need to make sure 12 over 15 is the same as all of those. So now we're going to go ahead and divide each of those out. 12.5 divided by 10 gives us 1.25. 11.5 divided by 9.2 gives us 11.25. So we can't just assume that because two of them are proportional that they're all proportional. We do have to check all three. 12 divided by 15 is also 1.25. So yes, it is, the two triangles are similar because all of our angles are congruent and our sides are proportional. Let's take a look at this one. For the sake of time, let's just find the value of y. Okay, so what I notice is I have ZV. So ZV has to be congruent to FA. Or sorry, similar. They have to be in proportion. So I'm going to set up that proportion. So I'm going to put this guy first. The one on the left is going to be on top. So I have 12 divided by 3y minus 1. So again, this quadrilateral is going on top of my ratios. Now I need to find something where I know both the values. Here I know 9, so I have CD, which is the same as WY. So I'm going to put this guy on top and this guy on the bottom. So now I need to cross multiply. So I'm going to cross multiply, and when I do that, I end up getting 9 times 3y minus 1 is equal to 12 times 6. And 12 times 6 is 72. So now we're going to distribute, and I get 27y minus 9 is equal to 72. So now I need to add 9 to both sides. And I get that 27y is equal to 81. So now to solve that for y, I need to divide both sides by 27. 27y. So I'm going to divide both sides by 27, and when I do that, I get that y is equal to 3. So my answer for that one is that y is equal to 3. Now let's talk about perimeter. So remember that the perimeter is the distance around the figure. So it's the sum of all the side lengths. Now here's a cool thing about the perimeters of similar polygons. Okay, if the two polygons are similar, meaning our sides are in proportion and we have all of our congruent angles, then the perimeters themselves are also actually in proportion as well. So for example, if we know that there's the scale factor of AB over JK, then I can actually say that the perimeter of A, B, C, D follows the same scale factor for the two, J, K, L, M. So then the two quadrilaterals have the same perimeter in that same proportion. So let's apply that. Let's take a look at number 6. So for number 6, we have a pentagon. So we know that ABCDE is similar to PQRST. So we need to first find a scale factor and use that to get the perimeter. Well, let's see. First of all, I see that this has 2 hashtags. So if this is 4, then guess what? This also has to be 4. And if this is 8, then guess what? This also has to be 8. If this guy here is 3, then this guy over here also has to be 3. So what I notice now is that CD is going to be congruent to RS. Well, I know RS and I know CD. So my scale factor is 3 over 4. So that answers that question. My scale factor is 3 over 4. Now I need to use that to find the perimeter. Well, thankfully for this guy right here, I was able to find all of the sides. So I can take 8 plus 4 plus 6 plus 8 plus 4. And when I add all of those together, I end up getting 30. Now notice I put that on the bottom because I chose to put this 4 on the bottom. I also have to put 30 on the bottom because we're dealing with the same polygon. Okay, same polygons have to go on the same part of the fraction. So now I'm just going to write x. X is going to represent my perimeter of this guy right here. So let's go ahead and let's calculate out the perimeter. So I'm going to take 3 times 30 and 4 times x. So 4 times x is equal to 3 times 30, which is 90. And now I want to solve this for x. So I need to divide both sides by 4, and I get that x is equal to 22.5. So the perimeter of that second polygon, or that second pentagon then, is 22.5. All right, let's take a look at number 7. So for number 7, okay, we want to find the scale factor and then find the perimeter. Well, again, let's use those hashtags to our advantage. Well, this is 4, so this also has to be 4. And this guy right here also has to be 10.5. This also has to be 7. On each of these, unfortunately, we're still missing a side. Okay, but I do know that AE corresponds to RV. So I know that my scale factor is 4 over 7. So I want to use that idea to help me get this guy down here. Since I know 6, I can use 6 up top, and I'm just going to call this x. I want to find ST, because once I find ST, I can go ahead and find the entire perimeter. So then I have 4 times x, and here I have 6 times 7. So 4 times x is 4x, and then 6 times 7 is 42. So now I need to solve that for x. So I'm going to go ahead and I'm going to divide both sides by 4. And 42 divided by 4 is equal to 10.5. So what that tells us is that this length on the side here, this guy right here is 10.5. So now I actually know all of my side lengths. It asks us for the perimeter of each polygon. Okay, so we know that this, when you add it all together, is going to, once you add all of that together, you end up getting 45.5. That's the perimeter of that one. Now we want to calculate out the perimeter of this one. So we're going to use the perimeter we just found and our scale factor. So remember, our scale factor is 4 over 7. And that's going to be equal to, now we want to set up our perimeter. Well, we don't know the perimeter of the small one, but we do know the perimeter of the large one. So I'm going to leave this to you guys. I want you guys to cross multiply and figure out what the perimeter of this is, and then go ahead and show me once you're done. Thanks for listening.